Hi, today we're going to be talking about quantiles. So we are going to consider the test grades of a class X, and we're going to say that it is normally distributed with a mean of 67 and a standard deviation of 9. A teacher wants to target the top 5% of his students to get the IB diploma. This means that he wants to know what grade corresponds to the 95th percentile of test grades. So to answer this question, we need to find K such that the probability of X being less than or equal to K is 95% or 0.95. This number, K, is known as a quantile. And in this case, it is the 95% quartile or quantile. So whenever we use technology on the TI-84, you must press second vars in order to get to the distribution menu. So when you press second vars, it says to find the value of K when given the probability, we use the inverse normal function, which in the calculator is invNorm. The TI-84 only calculates the value of K for the areas to the left of K, meaning using the probabilities that X is less than K. So to find the value of K such that the probability of X is greater than K, you will have to use the probability 1 minus the probability that X is less than K. So let's look at an example. The test grades of a class X is normally distributed with a mean of 67 and a standard deviation of 9. Find K for which the probability of X is less than K, which is equal to 95% or 0.95. So if I'm trying to find the value for which X is less than K, and is 0.95, remember the area under your curve is equal to 1. That's the total probability. So if I'm saying that X has to be less than a value of K to give me 95%, then that means I need to go from the left side of my graph and I need to be looking at 95%. So this is already 50%. So I know that 95% is going to be somewhere around here. All right. So now that I know that portion, then I can go ahead and label that this value here has to be K because this area, and let me use a different color, this area here is 0.95. So the way that I write it is that I'm saying that the probability that X is less than K is equal to 0.95. So what we have to do here is we have to look at our inverse norm. So I'm going to go to number 3. And it tells me the area. Remember, this is already to the left, so I put 0.95. I put my mean, which is 67, and then I put my standard deviation, which is 9. And I see that in 3 significant figures, that in order for this to work, K has to be equal to 81.8. So that is the value of K. Or we can say the test grade. The test grade has to be 81.8% or higher. All right. So number 2, it says, if X is normally distributed with a mean of 5 and a standard deviation of 0.6, find the value of C for which the probability of X is greater than C, which is 0.37. So what you have to understand here is it's saying that you want to find the value of C so that you have 0.37 if X is bigger than that amount. So that if I draw it, I know that this has to be like a boundary of where C could be. And I want 0.37 of it to be above that value. So from here, I already know that I have 0.37. So because I know that I have that, what I can do is remember the calculator only calculates the probabilities less than. So that means that the one that I need to use is I need to go to the left side of this graph. And I need to use this amount in order to find my probability. And this amount over here is the complement. And we have to do 1 minus 0.37, which will give us an area of 0.63. So here I can say that I am using the 0.63. So I am going to write it as the probability that X is less than or equal to C is equal to 0.63. Because remember, it only calculates less than. So when I do that second vars, I go to number 3. I put in 0.63. I put that my mean is 5. My standard deviation is 0.6. Remember, we have that X is distributed normally. And then we have our mean is the first number. Then our standard deviation squared. So I already know that 5 is the mean. 0.6 is the standard deviation. So once I do that, I paste it. And I end up seeing that C will have to be approximately 5.20. Right, 5.20. So now let's look at example 3. Example 3, it says, if X is normally distributed with a mean of 17, so I'm going to make sure I mark that. That is my mean. And 2.2 is the standard deviation. We want to find the values of D and E for which the probability of X being less than or equal to D is 0.1. And the probability that X will be in between D and E is 0.72. So if I want to mark it, the probability that X is less than or equal to D is only 0.1. So that's going to be somewhere around here. So I know that D will be here. And I know that the area is 0.1. And then it says E, the area between D and E is going to be 0.72. So it can be somewhere, let's say, around here. We can call that E. This is 0.72. All right, so in order for us to do this, we would have to say that if we know that if we have to find D here, we would have to say that the probability that X, excuse my pen is glitching, is less than or equal to D is equal to 0.1. We can go to second vars, go to inverse norm, and we can do 0.1. And then for the mean, we put 17. And for the standard deviation, we put 2.2. And once we paste it, we will end up getting that D has to be approximately 14.2. Now, in order to find E, we could say the probability that X is going to be less than E is going to be equal to 0.72 plus 0.1. So please make sure you are aware of that. We had to add both of the areas together, which means we're finding the probability that X is less than E is equal to 0.82. So if I press second vars and go to number 3, I will see that my area is going to be 0.82. I keep my mean and my standard deviation the same. And we will see that E would have to be approximately 19.0 in order for that to happen. If you have any questions, please reach out to me, and I do not mind helping. You all have a great day.